Hello guys, my name is Kazim Luashinaamo. You are welcome to another episode of my tutorials. Today we probably will not be talking too much. Yeah, I posted question. Question you can see on my screen. I posted it on my LinkedIn page. By the way, please, if you are not connecting with me yet on LinkedIn, please, I will include the link in this the video description. Please, I would like everyone to connect with me. Let's interact online and let's share knowledge and learn from each other. Okay, as I was saying, I posted this picture on my LinkedIn page and I had some brilliant and amazing answers in the comment section, and I've decided to, talk about the question and share my view and my perspective. A whole lot of people have talked about their view on the question, and I really appreciate everybody engaging with the post. Thank you very much for engaging, and I hope you continue to engage with me. Thank you very much, guys. And so, about this question is about structural behavior, and there are a whole lot of things that we consider when we see structures, and one of them is the support conditions. Basically, what this question is trying to test is support conditions. So, I'll be talking about how the support conditions have affected the behavior. So we have 5 options. We are asked to choose which of the options actually gave rise to the deflected shape. So before we will be able to analyze this question, I would want us to briefly talk about the 3 different support conditions that are present. Option A has pin and roller, B has pin and fixed, C has roller and fixed, D has roller and pin, and E has roller and pin also. We have the fixed, we have the pin, and we have the ruler in the question. So let's take them one by one. Let's really understand how these support conditions make our structures to behave. So from that knowledge, we'll be able to have an educated guess of how the structure is supposed to behave. So if we have, let's talk about a fixed support now. A fixed support being like this. So this is how a fixed support will behave. It will not allow movement along the x-axis. It will not allow movement. No movement. And also, it will not allow movement in the y direction. No movement also. And it will not allow rotation. No rotation. It will not allow rotation. So this is how the fixed support will make the structure behave in this manner. And there is something I usually don't like saying x direction and y direction, because that is highly dependent on the orientation of the support. Because the orientation of this support now will have the x direction this way, right? According to the orientation, it will have its x direction this way, its y direction this way, and we said it will not allow movement in this direction. So what if the support is orientated this way? If the support is orientated this way, you get to understand what I'm trying to say here better when we get to roller support. If the orientation is this way, what we initially called our x direction, it was perpendicular to the surface in which the support is lying. The support is lying on this surface. So the x direction here is perpendicular to it. But in this situation, the x direction is actually parallel. So instead of understanding how this these support conditions, instead of understanding how they behave by attributing them solely to X and Y direction, I'll prefer we use a more encompassing term or a more encompassing idea, which is, I would rather say it will not allow movement in the direction parallel to the surface which it lies, and it will not allow movement in the direction perpendicular to the surface which it lies. Because it's a fixed support, either ways, no matter how you orientate it, whether you orientate it this way or you orientate it this way or you orientate it this way, X direction and Y direction, it will not allow movement in any of the direction either ways. So, but you get to understand this idea. You get to understand the reason why I prefer this idea. When we get to roller support, you tend to appreciate it better. So now, let's move to roller support next. Let's move to roller. So when you have a roller support like this, a roller support will not. So now, this is the idea I'm talking about. Rather than saying it will allow movement in the x-axis, and it will not allow movement in the y-axis. I don't really like describing this concept this way, because what if this thing is reorientated this way and you are already used to saying it will not allow movement in y and it will allow in x? But according to this orientation now, that idea is wrong, because it will actually allow in this y direction, but it will not allow in this x direction. So this is where my preference for this statement comes in. So if you know that, if you say it this way, for the roller support, it will allow movement in the direction parallel to the surface which it lies, and it will not allow movement in the direction perpendicular to the surface which it lies. Pardon my handwriting, please. I'm just trying to be fast. Okay, so I prefer this. So now with these, when you understand these concepts like this, that means there is no way you orientate your roller. If I orientate it this way, it will allow movement in the direction parallel to the surface which it lies. This is surface which it lies here. This is surface which it lies. This roller will allow movement in this direction, which is parallel. It will allow, which is parallel, but it will not allow movement in the direction perpendicular to the surface which it lies. So this is surface which it lies, and this is perpendicular to it. This is actually perpendicular to it. It will not allow. also, if you orientate it this way, going by the statement, it will allow movement in the direction parallel to the surface. So here now, this is the surface which is lies. It will allow movement in this direction parallel to it, but it will not allow in the direction perpendicular. So I prefer saying it this way rather than just understanding by saying it will allow in the x, it will not allow in the y. Let's try to understand things by their core concept. So like that way we'll be able to tackle any question in any manner in which it comes. So we have talked about ruler, we've talked about fixed. Now let's talk about our hinge or pin. So which is this, right? Please let me add to it, the ruler will allow rotation also. To allow rotation. So our hinge will not allow movement in the direction parallel to the surface which it lies, and it will also not allow movement in the direction perpendicular to the surface which it lies. So that is it. No matter how you choose to orientate your hinge, no movement here, no movement here, no movement here, and no movement here. But mind you, it will allow rotation. It will allow rotation. Rotation is allowed here. So I hope you understand it up to this point. So a quick recap. We have our fixed, right? We have our fixed. Pardon my writing, please. We have our fixed. We have our ruler. And we have our hinge. We said fixed. What we have for now, if it is fixed, no movements this way and no movements this way. Also, no rotation. So x direction, no. Y direction, no. Rotation, no. Roller, it can move this way, yes, because it is parallel to the surface which it lies. It can move like this, yes. Can it move this way? No. Can it rotate? Yes. So x, yes. Y, no. Rotate, yes. So our hinge now, this x rotation, the x movement in the x direction, no. Movement in the y direction, no. Can it rotate? Yes. So x, no. Y, no. Rotate, yes. So how can you now, when you see a structure, how can you know that this structure is rotating? How can you know that this structure is moving? How can you know that this structure is not rotating? So before we tackle the question, let's see again. If you have a structure that is like, if you have a frame like this now. So if you want to, let me first of all talk about understanding that the structure is, say, rolling or say moving moving horizontally in the deflected shape. So if this is how it is being represented, so let's assume the deflected shape is drawn this way. It's just an assumption. So what you notice is that we have we have a translation from here to here. We also have a translation from here to here. So you can see the structure as moved here. So what this is telling us is that the kind of support that would have been here is what roller, because we said it is roller that will allow movements in the direction parallel to the level in which it lies. So from our definitions, we know that the hinge will not move horizontally that way, neither will the fixed. So that is how roller will make that thing behave. So and also another thing that we should know is that if you have a deflected shape like this, please let's look at this very well. If you have a deflected shape represented like this, you have it represented that way. Please let's take a good look at these two members, the way I've drawn them. This member and this member. Okay, let me erase this. So what will make this member behave this way is if you have what, we said it that a fixed support will not allow rotation. So if you look at this member, if you look at this member here, you see that there is no rotation here. The way it was represented is different from the way this one is represented. It is different. How is it different? When you look at this one, there is an angle formed here. I hope you can see the angle here. But there is no angle formed here. So that means there is no rotation happening here. But there is rotation happening here. So from our definitions, we know that it is what? A fixed support that will not allow rotation. And it is either pin or roller. This hinge also, right? It is either this or this that will allow this rotation. But how do we know if this is a pin or a roller? We will know because if it was to be a roller, it would have like displaced from this previous position. That's what we first tackled, to like a new position. So there will be a translation there. But since there's nothing of like that, it is only a rotation that we are having there. So definitely it is not roller, it is pinned. I hope it is clear. So now I think we can tackle the question. So looking at this now, the question now, this deflected shape, the member has translated from this point to this point. So from our previous definitions, fixed cannot behave that way, pin cannot behave that way. It is only roller that can behave that way. So let's see which of these options has roller on the left member here. Does this have ruler? No. So this can be it. Does this have ruler? No. This has ruler here. This has ruler here. This has ruler here. So we are left with 3 options, right? So now another thing is, when you look at this structure, this other member here, when the force is applied, it has made this other member to deflect, and the member did not translate. It didn't leave its base like the roller did, but there is a rotation. You can see the rotation we just talked about. There is a rotation here. That means the member here cannot be roller. It cannot be fixed, because fixed does not allow rotation, and roller would have translated. So it can only be the hinge support. So let's look for the one that doesn't have hinge on the right. Does this have hinge? No. So now we are left with D and E, which leaves us with the simplest option. The force could have only been applied in what way? For this thing to have moved this way, the force, it is only logical to know that the force was applied from this side. D and E have the same support conditions on both sides. So the only thing that we can use to distinguish them is the direction of load application. So it is only E that has the direction this way. So D is out of it and E is correct. So I hope we have tackled this question, and I hope it is clear. So, and basically, we need to know at the back of our mind that when engineers are designing their structures, they usually make sure that whatever deflections that will be occurring in that structure will not, we have a very small magnitude compared to the overall scale of the structure. And most of these deflected shapes that we do draw sometimes are usually well exaggerated just to understand the concept. And the intensity of the load you apply will always affect your deflection. So thank you very much for following me this far. I hope you understood everything, and please support this channel by liking and subscribing, and also commenting if you have any question. If you have any idea, any views you want to share, please share your insights. Let's learn together and grow together. Thank you, and see you in the next one.